Section 2, task 4. In this task, we need to find the inverse of fx. To find it, first we need to switch them. We switched it, and now we have to square the both sides. We'll get y equal x squared, and that's the inverse of our function. And the domain will be minus infinity and 0. Task 10. Here, let's write it. S is a set of containing elements 1, 2, 3, 4, 5, and T is a set of elements containing 1, 2, 3, 8, 9, and F, S, T, G, S, F equals the set of pairs 3, 9, 4, 3, 2, 1, 5, 2, and G equals 1, 2, 3, 1, 2, 2, 4, 3, and 5, 2. In the first case, A, we need to find F compose G. F compose G, you can write it as F side of Gx, and G. For G, it will be G1. G1 will be 2, and F2 will be 1. G3 is 1, and F1 is 8. G2 is 2, and F2 is 1. G4 is 3, and F3 is 9. And last, G5 equals to 2, and F2 is 1. And now we have the pairs. Is 1, 1, 3, and 8, 2, 1, 4, 9, 5, 1. Let's write it here. F compose G equals the set of these pairs 1, 1, 2, 1, 3, 8, 9, 4, and 5, 1. Second one, we need to find G compose F. It's G Fx, and let's start F1 is 8, and G8 is here. As you can see, here we don't have 8. It means that 8 is not the domain of G. Is not domain of G, so it's not defined. There is no answer. The third one is F compose F. F inside of Fx. F1 is 8, and F8 is, here we also do not have the 8 because it's not a domain. So F is not a domain of itself F again, so it's not defined. Four is G compose G. G inside of G. G1 equals to 2, and G2 is 2. Oh shit. Yo, I forgot. Okay. Next is G3. G3 is here 1. Yes, 1. And G1 equals to 2. G2 is 2, and G2 is again 2. Next is G4. G4 equals to 3, and G3 is 1. G5 is 2, and G2 is 2. So G compose G equals set of 1, 2. I forgot to write the pairs. 1, 2, 3, 2. Here 2, 2, 4, 1, and 5, 2. 2, 2, 3, 2, 4, 1, and 5, 2. So that's all. The next case is B. Show the G. In B, we need to find if the functions f and g are one-to-one and which of them are onto. So the first is here. Let's write it as t f is 1. Okay, 1 minute. Yeah, let's rewrite. 1 2 2 1 3 9 4 3 and 5 2. So here we need to write this 5 8 1 9 3 and 2. These numbers is the second numbers of these pairs, 8 8 1 1 9 9 and so on. And let's write a t. T is 1 2 3 8. T is 1 2 3 8 and 9. So let's check first if this function is 1 to 1. Yeah, this function is 1 to 1 because these numbers, they don't repeat. They don't repeat, so it's 1 to 1. Let's check for onto. So as you can see here in the t, in the set t, we used all of these numbers here. So we can say clearly that this function is onto, because all elements from t are used. So it's onto. And it's also bijective, because at the same time this function is 1 to 1 and onto. Let's check the function g. G is 1 2 2 2 3 1 4 3 4 3 and 5 2. So let's write the second numbers. 2 2 1 3 2. Let's check first if this function is 1 to 1. Yeah, this function is not 1 to 1 because here g1 equals 2 and g2 equals to 2 and also g5 equals to 2. It means that different inputs but the same outputs. 1 to 1 doesn't work like that, so this function is definitely not 1 to 1. Yeah, because numbers repeat here also. Let's check if it's onto. this function is not onto, because here in the set, as you can observe, we use here only three numbers, 1, 2, and 3. But here there is two more numbers, 4 and 5, and we do not use it in this function, so they have left. So it means that this function is not onto. Because 4 and 5 are not used. The next one is C. In C, we need to find the inverse of the function f. To find the inverse of some function, first we need to check if the function is bijective. Our function f, as we solve here, is bijective. So we can say that the inverse of function f does exist, and it will be, we just need to switch the positions of the pairs. So it will be 8, 1, 9, 3, 3, 4, 1, 2, and 2, 5. And that's the inverse of the function f. So let's move on. In case D, we need to find here the inverse of the function g. As I said before, to check if the function have the inverse, we firstly need to check if the function is bijective. As we solve here, this function is not one-to-one and not onto, so it's definitely not. Ami.
Yeah.
Okay. I'm sorry, and as I said, the function g is not one-to-one and not onto, so it's clearly not bijective. So we can conclude that the inverse of function g does not exist. Yeah. The last task, 13. A equals x r f g h, and the functions fx equals x over x plus 1, gx equals 1 over x, and hx equals x plus 1. Now we need to find the first g composed fx and okay. So g composed fx you can write it as g fx and we need to place the function f inside of g. So it will be 1 over x over x plus 1, and it will be equal x plus 1 over x. Second one is f composed gx. You can write it as f gx. Yeah, we need to place the function g inside of function f, so it will be 1 over x over 1 over x plus 1, and x 1 over x over 1 plus x over x, and equal 1 over x multiplies we're going to switch to x, 1 plus x, subtract them, and we get the answer 1 over x plus 1. Here also. Third one is h compose g compose fx. So it's f g f x. GF. So let's firstly find gfx. Oh, we found it here. Yes, it's here, and we just need to put this function inside of h. So h is, yeah, h will be x plus 1 over x plus 1, x plus 1 plus x, 2x plus 1 over x. There's the answer. And last force is f compose g compose hx. Let's first find g h x. GHX will be 1 over x plus 1, and FGHX will be 1 over x plus 1 over 1 over x plus 1 plus 1. And this one will be x plus 1. Will be x plus 2, 1 over x plus 1 over x plus 2 over x plus 1. Can subtract these ones, and we'll get the answer 1 over x plus 2. That's all. Goodbye.